So, welcome to the lecture series on digital switching systems. This is the first course, so I will be introducing what we are going to cover in the whole course and then how I will be actually proceeding. So, basically the idea is what we understand from digital switching is it has to do something with the switching. Switching basically is an action where either there is going to be a path. That is, I think, the most basic way of understanding. Most of the people understand it only this way, that usually they will use a switch to, for example, switch on their lamp, and there usually will be a power source and they will switch on or off. So, this is what basically is the switch, but we need to talk about digital switch, and basically switching functionality is what is more important. How it is implemented is a different issue. So, what we are talking about is not switching in the sense of electricity, but switching in sense of communication. So, usually what will happen is why we required actually a switching. Let us come to that. So, essentially it is a communication requirement. So, usually what will people will do for communication, there will be a transmitter. So, I am putting up a telephone here and telephone on the other end, and user 1 wants to talk to user 2, they can actually lay a line and they can start working on this. So, this is a point to point communication link which gets created between them and they will communicate. So, they can just lift the handset, they need to have some power source or to actually energize both the phones, and that is all. The communication happens whenever they want, but there are only 2 users, but this kind of communication system will actually not work. So, usually what we desire is we are going to have, instead of this, we would like to communicate not with one person, but everybody whom I know. So, if I actually know a lot of people, so in general they can be 1, 2, 3, 4 and n. So, if I still want to create same kind of communication mechanism, it is a basically long distance telecommunication thing, then what I need to lay my wires all the way to every user which I know, but this is true only for one, same is going to be true for node 2, same is going to be true for node 3 and same is going to be true for node 4 and so on. So, usually what you will require is n into n minus 1, this is which is by 2, which is NC2 bidirectional links. Bidirectional actually means where the information or voice can flow in both the directions. Now, when such a scenario actually happens, the number of wires which are required, you can actually observe is going to have a complexity of O(n) square. Now, this is not acceptable because as my number of users in the communication networks are increasing, number of links which are required are going to be too high. And now, what will be the utility of basically of each link? If we take a case whereby only a user talks to only one another user, it is a one to one communication. In general, total n by 2 communications actually can happen at any point of time. So, what you will figure out is that there are only n square communications happening and I have invested money on n into n minus 1 by 2 links. Okay. So, n by 2 basically is the number of communications. So, utilization is basically number of links which are utilized divided by total number of links. So, I will be using n by 2 links and I have total number of links which is these many. So, this will be the maximum utilization factor which you can actually have in such a scenario, and once you solve this will turn out to be 1 divided by n minus 1. So, this is the utility when every user is talking all the time, it is that kind of situation. Now, when this happens, what you will find that as my n grows, in limit when n goes to infinity, when number of users become very large, my utilization will go to 0. Now, this is not acceptable because each cable which you are going to lay will cost you something and its utilization is going to be low. So, the cost per unit of call is going to be very high. But if you carefully observe, the cost is because you are laying so many cables and a user is using only one of them at any point of time. Now, this is a full mesh network actually which I have created. Switching is happening here, it is done by users. So, if as a user I would like to talk to, say 1 wants to talk to 2, he will be now switching off, basically there will be some person sitting in here which will be having a handset and a microphone, they have to be connected to onto this particular line. So, other lines will not be used, and tomorrow after some time, for example, if he decides that I am not going to talk to node 2, but I want to talk to 3, he will stop, he will take out this handset and microphone from line 1 and then will connect to line 2. So, he is doing switching in that sense actually. So, this all switching functionalities are happening at the user end, not in the network. Network is purely passive in sense of switching actually. Now, question is, my utilization also becomes almost 0 as n grows very large. So, my cost becomes very prohibitive actually. So, this kind of communication systems cannot be built. Okay. So, only kings or top bureaucrats can actually afford a hotline running all the time dedicatedly for them. There are nothing but dedicated hotlines being created between all possible pairs of users in the whole community. So, that is what actually is happening. So, there will be a better situation I can create. I probably can ask, what I can do is, a better option is, let me create a central switch. Now, there where the actual switch functionality will come, and let every user gets connected to this. So, I am connecting all users to this thing. Now, how many links I need to actually lay for n users in this case? It is not going to be NC2, what I require is only n links. Only problem is, I need a mechanism whereby if one wants to talk to 2, he should be able to tell this box and it should be able to create a path between 1 and 2. Next time, for example, if this guy 1 decides to talk to somebody else, say 3, so a path can be created in this fashion. So, I am now creating switching functionality is being implemented by this box, and that is what we mean by a switch. And when we represent my voice signals or data, whatever it is being transported between users in digital formats, I will call it a digital switching system. Now, in general, in common sense term, this is also known as exchange. Telephone exchange is what the word which lot of people are aware of. So, commonly it is not called as a switch, is a technical term, but telephone exchange is what people commonly know of this particular system. So, this basically exchange is nothing but a building whereby you put all these kind of switches there with all power supply, everything, all users get connected. Now, if all users here will talk all the time for all 24 hours, then what will happen? What you will find is that you will have for n by 2 possible communications, n links will be consumed and there are only n links. So, utilization will be n by n, which will be going to 1 in limit when n goes to infinity. For that matter, for whatever be the value of n, it will always be going to be 1 in worst case scenario. So, utilization is not 0, it is independent of n. Now, that is a very good thing. Once it is independent of n, so my cost is going to be very, very low. Of course, you can see I am not using a number of links is not n into n minus 1, which is O n square, but it is O n now. So, this system will work wonderfully well. We have to still figure out how this switch will get implemented, because now important thing is that the node has to talk to this switch has to understand the logic or whatever link or whatever destination which one would like to connect to. In earlier case, one simply decides that I am going to connect to 2 or I am going to connect to 1, and as per that it makes a decision. Okay. So, there is some intelligence which need to sit in this box. Now, there is another problem actually. I have been assuming that all links are being used 24 hours, almost all the time. Somebody is busy on the equipment, he is talking. So, I am taking an example of voice communication, but this is true even for data. Okay. Now, if you are not going to work talk only for say half an hour a day. So, remaining 23.5 hours the line is empty, and especially if for example line is very long, say for example I am in the capital city of Delhi, we have a central exchange or central switch, and all users all across India are connected to that place, and I have got dedicated wires. So, think of number of wires which you have to lay is going to be huge, and the cost on each wire is going to be also quite large, because it is about 450 kilometers from here, from Kanpur. If I have to lay from Kanpur 450 kilometers, from Bombay 1300 or so. So, this is going to be a costly affair, and you are going to use only for 1 by 24, 1 by 48 hours, for 1 by 48th of the day, only that much fraction of the day you will be using it. So, can I actually take care of even this? So, idea came, okay, what we can do is we can create a smaller switch within a city and let all users gets connected to this, and when they want to communicate, I have to ensure that this length is as small as possible, so that my cost of this digging, because the utilization of these lines are very small, they are connected directly to the users. So, their cost has to be as low as possible. So, the length has to be kept small. Now, I can create in another city another exchange of similar kind, and I can connect the users there. Now, I can connect few lines in between these two cities. So, what will happen is these are known as trunk lines, and I keep them in few numbers, not a very large number. So, I did not actually lay a very thick cable, and what will happen is whenever I call this, even if these guys are talking only for half an hour a day, I can keep these lines busy for, because everybody is not talking all the time. So, people will talk at different times of the day. So, I can probably make the utilization of these lines to be very high. I can make them to be say busy for say 14 hours in a day or 16 hours in a day kind of thing. So, the per unit call, the cost is going to be lower for a trunk line in this case. So, now the thumb rule in any network design, which you can actually perceive from here, is that in any network, whichever is a costly link, your utilization factor has to be high, as high as possible. So, usually we keep them about 0.8 to 0.9 roughly in between that range, okay. Because this number of calls which are being made simultaneously they keep on fluctuating. Sometimes there will be too many people calling, sometimes less, but the average we would like to keep around about 0.85 or 0.9, roughly in between that, and remaining is for taking care of if suddenly the large burst of calls will come in for that period, but that actually reduces the cost. So, wherever the cost is high, reduce the length to reduce the cost. So, here utilization is low, cost is high, and henceforth we keep the length less. Now, this actually creates kind of a network. In general, the most of the telecommunication networks or data networks are created in such fashion, and these kind of things where users are connected, this particular portion is known as access network. Actually, this is access network, and of course, then you will have, this is also going to be access network, and the part which is there in between, this is known as trunk network. Trunk or core, that is a word which is being used depending on whether it is a voice or whether it is a data. I will actually then again we will basically merge everything into data network ultimately. Now, in between it is also possible that I might connect to another exchange, something like this. So, there are no users connected to this one, but it is permitting the calls to go through, it is using like an interconnect, we call it a transit exchange actually. Okay. So, now we at least understand that what is a switch functionality. Switch functionality is in this box, and we need to understand how this gets designed actually, how we can implement this. So, in earlier days how we used to do it. So, in earlier days this we used to have something called manual telephony. I think This is not being used currently, not being practiced anymore. Most of them are now automatic, fully automatic exchanges. In fact, now we are moving over to voice over IP based systems instead of manual exchanges. So manual exchanges were typically was very simple. These are all analog, there is no digital thing here. A simple voice is being just captured and is being transmitted. So usually in this case a person, so I have given these telephone instruments at the various houses, they are connected to an exchange. Subscriber exchange we call it, or access network. Then there is a backbone or trunk, there can be other exchanges. Now each exchange there will be a person sitting there, a human being. So earlier days this is what how the telephony actually started. Automatic exchange came much later actually. So a simple thing is the protocol which can be followed here is you lift up your handset, and that handset once you lift, there will be a board here sitting and somebody will be sitting, there are pins or jacks which are connecting to your wires for all users, and for making a connection you have to create a jumper wire, or you have to take a wire and put your pins into these slots, and which will make the connection. Okay. So that is how it can be done, and usually there will be a display here depending on whether you have lifted the handset or not, and there will be users, there will be an operator which will be operating this particular thing. So whenever you will lift the handset, the circuit will get completed and a light will glow here. So once the light glows, the operator will see the light, and of course if operator is not there, nobody is going to put through your call. So once he or she actually sees the light, he has to put in an earphone which is maintained by this person along with a microphone. Okay. So this guy will then actually put his jumper into your port, so that now he or she can listen to you, and you can, and she can also talk to you. Now once she greets you, this light is being glowing and she knows that you have she will talk to you, and she will ask you after greeting that which particular number you would like to get connected to, and you will tell the number. Now remember, whatever steps I am telling are exactly followed even in current day telephony. So this basically gives the framework of how the protocol is going to be built, and once you tell the number, this lady will probably have a music generator or something. So that music generator will be connected to you, and this particular thing will be taken off, and she will note down the number on which you would like to make the call, and she will search the directory that on which particular port that number is connected. If that number is not in the same exchange, it is in the next exchange, she has to then talk to the person who is there in the next exchange, same protocol, and then she will tell that this is the number which her subscriber need to be connected to. Okay. So in this case I am actually assuming that the other subscriber is in the same exchange. So she will pick up the other person, she will find out, yeah, there is somebody there is already there on that exchange. So there will be another box. So meanwhile remember, the music is being played back to this guy. So this is like a search tone which you actually see. So this music being played to this guy. For the next person, once she knows that this is the person whom the call has to be, who is that other person to whom the call has to be made, she will use another what we call ringing generator. Okay. So this ringing current has to be applied from here onto that particular jack. If this is a destination, ringing current will be applied here, which in turn cause the phone here to ring. Ringing current usually is not in the audio band, this is actually the current power which is being modulated, which will cause the ringing of the phone. So phone will start ringing at this end, and once the user comes here and he will check there is a current, he will lift up the handset. The moment he lift up the handsets, the light will glow here corresponding to that person, and once the light glows, the operator has to now take this particular ringing current out, so that now there is no more ringing here, and then she will put her own jack here in this case. So, this particular thing will be taken off. So, her own jack will be put. Now, she can talk to the destination, she will tell that this is the guy who want to make a call to you, would you like to take up the call, and once this person agrees that he would like to take up the call, she will actually have a record register, we call it a call detail record nowadays, CDR, and the CDR she will make an entry that who was the person who made who initiated the call, who is the person to whom the call has to be made, at what time the call was made, and then there is a call closing time which she will actually enter at the end of the call. Okay. And what she will do is, once the both people agree, she will just put a jumper wire, she will take out her own jumper and then she will connect a jumper wire between the two people, and once the call is through, this light will remain both glowed up because their handsets are lifted, because this is being driven by the DC current circuit which is gets completed when you lift the handset, and they will talk, they will keep on talking, and once their talk is over, any one of them can push back the handset. Once that handset is put back, this lady will actually observe the light is off, and that point of time she will note down the time when the call was off, call was actually completed, and once the one of the light is off, she will take out all the jumpers, and these guys will simply put their handsets back on the cradle, okay, and the call will get completed. Now, this is exactly still nowadays the phone call does get completed in the same fashion, except now complication will come if there is going to be another operator sitting here, another console board which is sitting. So, if the call has to be through a trunk route, so it usually takes more time, because the user will tell the operator, operator will tell the next operator, and this operator will also keep this operator on hold, and then and so on, and each operator will keep their own CDRs at their end, and as per that they will start doing mutual charging from each other. So, based on this, essentially then the bill has to be generated at the end of it. Now, this is a very cumbersome process, but this is how the telephony actually started, it became popular, but remember the human cost involved is pretty high, and there are chances of mistake, there is a chances of making a mistake in call recording, and then henceforth generating the bills. Now, this was the most elementary switch which we can talk about, this is known as manual switch, okay, or manual exchanges. In still defense, I think some places, if everything else fails, this will always work kind of thing. So, this is still used as a backup, especially in defense organizations, but I think nowadays most of them have moved on to packet switch based systems. Now, another important thing which I would like to tell here is that what I am talking about is a circuit switch, okay. So, this circuit switch technically means I am creating a path from source to destination as it is intact throughout, and once a path has been created, the information or voice just simply flows, okay. So, currently as of now it is circuit switching, I will tell at some point of time where we will move over to packet switching later on, because once we complete all the theory of even this circuit switching, then it will become much more clear. Still digitization has not started in this case, it is still analog. Now, this manual telephony is a problem, because operator can always listen to what you are talking to the other person. So, you have to either talk in code words if you are talking to other person, if you want to maintain secrecy, otherwise information can leak. So, there was A.B. Stauger actually, I think was the person who realized this, and he started working on automatic exchanges. He said, I think this manual operators need to be removed and we should have fully automated system, and he ended up with something called Stauger exchanges, and it was purely an electromechanical system, and it was built with very simple devices. So, one of the elementary thing, for example, it simply uses a ratchet wheel. So, A.B. Stauger actually built up an automatic exchange which was pure electromechanical thing, and basically it uses electromagnets for creating mechanical motion, and thus creating contacts between electrical contacts between the input and I/O ports, input and output ports, and thus creating switch basically voice paths. So it uses basically two kind of elements, one is uniselector, and in fact there is a whole lot of logic which got embedded using relays actually for implementing this kind of system. So or flip flops which are actually used, but the basic switching elements was only uniselector and two motion selector. So I am just showing that how it would have been looked like. So unimotion selector usually will consist of a hinge which will be like this, and this is the hinge, this can rotate around this part. So there is a spring connected to this, and there is a hook which is there, this is again connected to the spring, and there is a hard surface. So it is always trying to pull this thing upward, and this is being tried to pull towards this side, okay. And then there is a electromagnet which is here, and whenever you actually supply current to this, so this will actually come down and then it will go up once the pulse is over. So with every pulse there is a motion of this particular bar coming down and going back up, and as a result, and there is a ratchet wheel which is being used on this side. So every time this motion, this pulse happens, this wheel actually moves by one teeth in this particular direction, because when it comes down it will engage with the next teeth because of these two springs, and when it goes back in the return, this wheel is going to rotate, and this can be used to create now the central, there is a current which is coming, and this is a wiper this is going to make an electrical contact, and I can actually have on this circle many points where every time it rotates it keeps on moving here. So I need to have mechanism to take it back to the 0 position. So usually it will count from 1, 2, 3 and till 0, and then it will come back to an home situation when there is no connection. So these are like outgoing ports. So usually it will be like one input, it is a switch of this kind now. So it will have 1, 2, 0, the total 10 outgoing ports, and this can rotate and connect to any one of them. So this was the uniselector which was actually used, and this wheel actually should not go back when it is, this electromagnet is working. There is always a stint which is put, so this is a very simple drawing, and this is what was the uniselector which was invented by him, and he built up what is known as Strauger exchanges, okay. And this is a reverse drive type of ratchet wheel. We call it reverse drive because when the pulse is switched off, at that time there is a reverse thing, when it is going back at that time the ratchet wheel will move. Reverse drive type ratchet wheel is mechanism. So there are other mechanisms which also people have built, and this is what is known as a ratchet wheel actually, what you are seeing here. So this was the one element which was built, and secondly what he built was a uniselector, that is what he designed. So the other one was actually two motion selector, it required two electromagnets to actually work. So one was a straight bar which is going to have gears on this. So as this bar moves, and then of course there is also a gear drive, so this can move upward and downward. This vertical motion happens because of another electromagnet depending on the pulse, and this motion happens because of this bar. So it will turn into rotation of this thing, and I can then connect a wiper, and these are the connection points in one plane, similarly in another plane, and so on. So you can actually usually have this, actually means this will move into these are like 10 points being there in the one plane, and there will be 10 such planes. So, total 100 actually outgoing points and one incoming point which will be there. So, this was used to work in 2 dimensions using 2 electromagnetics. Basically, you require pulses for driving this kind of thing. So, this will work from 0 0 technically, yeah, I call it 1 1 2 0 0, that is the way, because 1 is always what starts, 0 actually means 10 pulses. And of course, there are many control circuits which are built using relays, and these are integrated with these kind of things. Okay. He also now started something what we call a concept of common control switches with this. In this case, the control circuitry usually is going to be common, which is going to be then used for different uniselector and 2 motion selectors at different point of time depending on requirement. It is not all the time. So, common control switches were actually slightly complex, but the amount of hardware required is going to be small. Now, remember, all these are mechanical components, their failure is going to be pretty high, and as a result their maintenance cost is also very high. So, using less amount of hardware always makes sense. Also, direct control switches were also built, where the control circuitry was directly integrated part of the uniselector or 2 motion selector, but they were actually having a problem because of the lot of failures which were happening in the exchange. And of course, here also for the first time now the different kind of circuits came up, now which I can just actually mention what were the circuits which were built. Of course, with voice over IP coming in, most of this will not be required. So, various circuits which were built were like this. So, one was a guarding circuit. So, in this case what happens that whenever you are actually trying to set up a call, you actually use a one particular uniselector and call is still not through, but you have made the connection. Okay. So, at that point of time you have to actually set the status of that uniselector to be busy, so that no other call should actually try to capture it and use it for some other call. So, only when it is freed up, then only it should be used. So, it is basically maintaining the status of each uniselector and 2 motion selector. So, it was basically purpose was for that purpose. Second was the impulsing circuit. So, idea here is, again remember, the electromagnets are being used to drive both the systems. So, whenever you have to now move this particular arm onto any one of the connection points, you need to give certain amount of power. So, when you are giving a signal, the power is going to be small, it is only signaling pulses, and you have to now convert it to a drive current, and we call it a impulsing circuit, which will generate this much of power or drive current, so that these electromagnets can move these arms to appropriate point. So, basically it is like a power amplifier. Then similarly we have a homing circuit which was built, which is required. So, once you have made a call and call is over, this actually should come back to its home position. All either uniselector or a 2 motion selector both have to come to their 1 1 position, or there is a home position before 1 1 where they should come, and then again you can give the pulses depending on which number you have to connect, you want to connect the incoming port to which particular outgoing port you want to connect to. Basically based on that you will give the number of pulses. So, that for putting all these things back to home position after a call is over, we require a homing circuit. Now, this is another innovation. In the manual telephony, the lady was actually writing on a register the source, destination, the call start time and call end time, so that the bills can be generated. Here the bills were generated using a metering system. So, usually the things which were the way it was used is, we were having kind of a pulsing system. So, maybe say every 6 seconds there is going to be one clock pulse which will be there, or every second there is a clock pulse, and whenever the call is through, at that point of time this timing, the clock thing is also fed to a counter, and there is one counter for every user actually sitting in the exchange. So, these counters are nothing but kind of dials, so like meters. So, whenever call is through, this meter will start counting, and based on total count in the whole month, the bill actually can be generated. And if there is a long distance call, you might probably will connect a faster clock to the meter. If it is a short call, short distance call, you will be connecting a slower clock to the meter actually. So, that was the metering circuit. Then there was a ring trip. These were conventionally used now. So, ring trip circuit is whenever you are actually applying a ringing current, the bar is ringing of the for the destination user, and it is a powerful current which can actually transfer power to the bell, so that the sound can be very large and people can listen that there is a call coming in. The moment he lifts the handset, this information will come back in form of a electric circuit getting completed back to the exchange, and that time this ring trip circuit will actually get activated, and the ringtone generator will be disconnected from the subscriber. Earlier it was the operator which was doing it, now it has to be done through this particular circuit. And then of course alarm circuits were built. This was for administration purposes. So, for certain kind of faults, the alarm will start beeping, and then at least the maintenance guys will figure out that there is a flaw in the system, they can come and rectify it. So, this actually improves the maintenance. This kind of system were not very they actually have been in use for a long time, but there was a lot of this mechanical problem, dirt, oxidation of the contacts, and then of course is a mechanical thing. Maintenance is going to be pretty tricky, people have to be well trained for doing the maintenance thing, then this need to be improved. So, ultimately again the invention being made to take care of this particular thing, and people came up with an idea of something in the capsule and saying totally doing away with electromechanical things. So, there is no motion, there is no pulse, there are no gears. So, they will not gears will not get damaged over time, and you need not replace them, you need not do this, all kind of machine maintenance will not be required. So, ultimately idea came, there let there be a glass bulb which is sealed, and I can put an inert gas inside. So, there is no oxidation problem also. So, connection quality will also be good, and I can now actually have two simple wires, and whenever they actually just snap, they will connect to each other, the connection is on, otherwise it is off. But how to control it? So, then you can put the electromagnets. Similarly, you can put an electromagnet here. In fact, yeah, I have done it incorrectly, I will just rectify the figure. So, this particular part will be in the glass, this particular thing. So, this outer electromagnet will be outside the actually glass bulb. Okay. So, whenever you will actually put energize this electromagnet as well as this electromagnet, so this will be pulled downward, this will be pulled upward, and there will be going to be a connection which will be snapped in, and the moment any one of the electromagnet is switched off, the connection will be broken and voice communication cannot take place. And we call this thing as a cross point. Okay, this is a cross point, this is electromagnetic thing still, and this cross point now can be used to build up the basically the switching module, and this particular switching module which was built is known as crossbar. So, how you can actually make the connections with this, that is the question. So, very simple thing is, for example, there are 4 users which are connecting in, there are 4 users which are connected. So, technically I am now splitting, these are not bidirectional lines, these are unidirectional lines. So, signal comes in, signal goes out, both are for user 1. So, I will connect them together and I will use something called duplexer. So, it converts bidirectional into two unidirectional things. So, one is where the signal enters, one where signal goes out. So, this will I will doing for all other users. So, I can call them 1 prime, 2 prime, 3 prime, 4 prime and 1, 2, 3, 4, and now I can connect them, and that is why we call it a cross bar, because there are many bars they have been crossed with each other, and at this point between these two elements I am going to put this cross point which I have talked about. This is the cross point. So, n by n switch, so n users connected to n users, I require n square cross points. Now, that is the only problem here. This can be reduced by using only upper triangle or lower triangle, because I can connect 1 to 1 through this of course will never happen, but 1 to 2 connection can be made through this cross point as well as from this cross point. And if it is a unidirectional, I require both the cross points to be operated, and if it is bidirectional, for example, this link can be bidirectional because this is nothing but mechanically I am connecting the wires, signal will travel in both ways. So, I only need to operate only one of these two. So, it all depends on this. So, most of the time these electromechanical systems are going to be electromagnetic systems are going to be nothing but bidirectional elements input IO ports. So, I need not use this lower half, I need to only use. So, 1 to 1 connection I will never make because that is not required, because the same user. So, I will be only using these elements for building up the complete switch. This is known as upper triangle actually. So, this actually means n into n minus 1 by 2 cross points will be required. In this case n is 4. So, 4 into 3 divided by 2 which is 6, and you can see I require 6 cross points here to build up the cross bar if all ports are bidirectional ports. Okay. Now, question is how to operate it, how to set up the paths, that is an issue. So, I can stop now and then probably we can discuss how the algorithm is going to be worked out for operation of this particular switch. So, that we will see in the next.